So I am Dr. Lal, and Professor Pius, he's also part of this. He'll be, I think, from when you start doing the in-depth specialization, then we'll both be involved in doing the actual hands-on machine learning stuff, okay? For today, it's just basically getting an idea of what it is and how it's related to different aspects of machine learning, like artificial intelligence, data science, data mining. So we are just going to look at that in an overall picture, okay? How do I move this? So basically, this is the outline of what I want to present today. We shall look at machine learning. Then we look at different types of machine learning. We have got supervised learning, unsupervised learning, reinforcement learning, okay? And then we'll look at some common machine learning algorithms, and then we'll see where they are applied. And then we'll also look at how they're related to different fields of machine learning, all right? If there are any questions, please, you must just let me know as we go along. So if I have to, you know, the most common word or the confusion basically is what is artificial intelligence and how is it related to machine learning. Well, fundamentally, they are more or less they are linked to each other. You can say machine learning is a subset of artificial intelligence. And what is artificial intelligence? I've defined it here. So the goal of artificial intelligence is to create a machine that can mimic the human mind, all right? It is to look at how human mind works. So it needs, to do that, it needs learning capacity. So it is more than just the learning. It also involves knowledge representation. How does the reasoning happen in terms of machine? And how do we represent abstract thinking, right? So all that is part of artificial intelligence. It's related to the way we think, okay? Whereas machine learning is a process of learning. How do we learn? So it says that machine learning, on the other hand, is about writing software that can learn from past experiences. Okay, and it is quite related to data mining or statistics than, in fact, it is more to the artificial intelligence as such. All right? So we'll look at more in details what is learning now. In general, all right, I'm not talking about machines in particular, but I'm talking in terms of human beings. How do we learn? All right, so these are some of the definitions, informal definitions of what learning is. So if you look at the first one, we say learning denotes change in a system that enables a system to do the same task more efficiently the next time. All right? If I read that again, it is a system that it enables a system to do the same task more efficiently the next time. For example, when we have got kids, or kids when they learn how to tie their shoelace, right? In the beginning, they really struggle. You know, it takes time for them to understand how it is, and then slowly, with more practice, they become better, and they reach a stage where they don't even think. It's very easy to tie, isn't it? So that is learning. It has happened from not knowing anything, then they have performed the same task, and with that experience they have learned how to do it, okay? So that is what learning is about. Another definition given by another scientist or researcher is learning is constructing or modifying representation of what is being experienced, right? So whatever you experience, you want to try and modify your thinking based on that, okay? You have to show that you have learned something from whatever you experience. For example, you are doing your master's now. Now if you're thinking or if you're learning, if you don't learn anything, obviously your thinking will be still that of a B.Tech guy. Am I right? So with time we have to show that we have learned and we modify the way we used to think after you have learned something. Again, another definition is to make useful changes in our mind. The way we think, the way we behave is all part of learning. Now we look at machine learning in particular, right? The meaning of learning. So we say machine learning is the study of algorithms that improves their performance. Remember, it's the performance of the algorithm at some task with experience. More or less the same stuff as we looked at tying the shoe. With experience, the person starts doing it much quicker, more efficiently. Instead of taking 5 minutes, now it takes 1 minute to do that. So the machine also, we say that machine has learned, or an algorithm has learned something if it performs the same task with experience, okay? So it starts improving its performance with experience. Are you happy with that? Right? And then I'll give you a more formal definition of what is machine learning. So if you look at that, it says that a computer program is said to learn some task from experience if its performance P at the task T improves with experience E. So if its performance on doing a particular job improves with experience, then we say that a learning has taken place. All right? An example of that is if I've got a computer, we say that, okay, the computer program is said to learn. In this case, we are playing checkers here, right? So if I look at this, the computer program that learns to play checkers might improve its performance as measured by its ability to win. Okay, so we are looking at what is the performance criteria is the winning part. Now, that's what we want to do. Add the class of the task involving playing checkers. So the job is to play checkers, right? In the first case, it was to tie shoelaces. And then through experience obtained by playing game against itself or against somebody. So as it goes around doing the same job several times, it is supposed to improve its performance. Okay? Good. Okay, I've got a few more informal definitions, not really very important. Okay. And then now how does it relate? How does machine learning relate to different fields? It's quite a multidisciplinary subject. So if you can see there, it is related to artificial intelligence, it's related to statistics, information theory, databases, all right? Then cognitive science, decision theory. So it's quite interlinked so people from different areas also are able to apply machine learning to whatever the problem domain they come from, okay? To me in particular, I think statistics is very important if you want to take this machine learning a serious profession. You have to be good with statistics. That's the minimum that you need. And then obviously the domain knowledge of what area you're applying to. So you need to understand that as well. Okay, so we have looked at what learning is. We have looked at what machine learning is. Now we want to see what are the flavors of machine learning. What are the different types of machine learning? Now basically there are 3 types of learning. The first is the supervised learning, which is also known as classification problems, all right? The second one is the unsupervised learning, that is normally clustering, and then the reinforcement learning. We'll go into depth in each of these, all right? So what is classification, what is clustering, what is reinforcement learning is what we shall look at now. Now, important thing. So with supervised learning, the goal of supervised learning is to study many labeled examples and then be able to make predictions about the future instances. Now I've underlined labeled example, right? Now what do I mean by that? Let me quickly show you a simple example and then we'll come back to this slide. Let me just move forward. All right. Now, if you look at that table there, this is a sample of the price, the house of a pricing, all right? Depending on different factors. For example, what is the size of the house? I've shown on the extreme left here, right? You've got 352, 324. So these are the house sizes. We want to, and then I've also got in my data the plot size, all right, which is the next column. And then I've got the number of bedrooms, because my house cost depends on these features. Okay, there are many more, but I've just taken a few here. So obviously the house price would be related to the size of the house, right? You would expect that a smaller house would cost cheaper, it would be less than a bigger house. So the bedroom, number of bedrooms, the more bedrooms, I assume that the cost will be higher. Then also we are looking at the kitchen itself. Is it like, does it have granite top? Is it like modern enough? The bedrooms or bathroom, has it been upgraded or is it old-fashioned? So all this will have a bearing on the cost of the house. So here is a table that says that, okay, for a house of size 352 meters with 919 land size, plot size, 6 bedrooms, the kitchen, granite kitchen, no, it doesn't have. Bathroom is upgraded, no. The selling price would be 2 million and something, all right? That is what the data says. Similarly, I've got other sizes and the price, selling price of that one. Now in this one, what I'm trying to do is that I'm trying to predict, for example, if you look at the last row there, it says that what would be the price of a house that is 319 square meters and the lot size is 966 and it has got 5 bedrooms, kitchen has been updated, bathroom has been updated. So what would be the price of this thing? Now if you look at that data, the one that we are trying to predict, the last column, the selling price, that's what we are interested in, right? Now that is known as the label, all right? So that is the thing. So we need label diagram. If I go back to the old slide, so when we say the goal of supervised learning is to study many labeled examples, means examples that have got, the output that we are interested in, and then be able to make predictions about the future instance. As I showed you, what would be the cost of the last row. So that is where that now machine learning has to come about. It must look at the data, it must study the pattern, come up with a pattern, a model, and then use this new instance to predict what the cost would be. Am I making sense? Yeah? Good. I don't know. I just see. No, you must tell me if I'm talking sense or not. Well, it's relevant only if you're interested in this field. So I can't. So okay. So if I represent that same statement in a more diagrammatic fashion, I've got, these are my datas, all right? The training data, data can be in the form of text, it can be in the form of documents, images, sounds, what have you, all right? And obviously, because it's supervised learning, we also need the label, right? What is it that we want to do? So these two information is then, okay, before we feed it into the algorithm, we need to do some feature selection kind of stuff, all right? Which are the features that's important? We will look at some real example as you get into depth later on. So we'll see how to actually do feature selection, how to clean the data, the pre-processing of data, everything. We'll be using Python, for example. R will be used. We'll show you also certain examples using MATLAB, okay? So you will get a good feel of these tools and how to apply these algorithms to a set of data that we'll play around with. So having got the right features, we want to choose a particular algorithm, all right? And that algorithm now, the algorithm then looks at the data, finds a pattern of what we are expected to do, and then comes up with a predictive model here. So all this data is fed here, it learns something, and it gives us a model. And then for the new data that we want to take, again, that we apply to the model, and then we get the result that we are interested in. That is the normal cycle of a supervised learning predictive model. Okay? Is that clear? Okay, I don't know if it's clear, but you are saying yes, so I assume it's clear. Okay, getting back to this problem. So here this is what I've called as linear regression. Okay, linear regression is a technique which falls under the supervised learning. It's linear because if you look at this line that I've fitted to my data. Okay, these are the data, all right? These are the points that I've got. For example, this is my the size of the house, and this is the price of the house, all right? So I've got, for example, I've got a data there which is slightly more than 200. It could be, I think, that one, right? And the price of that is 1 point something. So it is somewhere there. So I've plotted all this data. What do I do next? Having got the data, I need now to fit this data to a particular curve, all right? And because this is a linear regression problem that I'm doing, it's a straight line that I'm interested in fitting. Now you can see the equation of that y is equal to something x plus a constant, all right? And because it's a first order polynomial, it's going to be a straight line. If it was a second power, you could get a curve there. Now I've fitted this line, and once I've got this line here, so if I want to know the cost of any other house, for example, what would be the price of a house that is 375 square meters. So from 375 you'll go all the way up there, and then you'll go that side and you'll see the price of that. So that is how you do the prediction, right, using linear regression. There are many other techniques. There's also logical regression, there's support vector. There are many other techniques which we'll look at, right? So let's not get too worried about it. Okay, here is another technique which is very commonly used when we are talking about supervised learning. That is called decision tree. Decision tree is, again, it's an algorithm which does what? Helps us in predicting something or coming up with a certain answer. So if you look at this particular data set I've got there, if you look at it, what do we have? We have got the outlook, we have got temperature, we have got humidity, we have got whether it's windy or not, and then whether the person plays. This is for a tennis game kind of thing, all right? So it says that, for example, if the outlook is sunny, and if the temperature is hot, the humidity is high, and it is not windy, then we don't play, all right? This is the data I've got. If, for example, if it is overcast, it's hot, the humidity is high, and it's not windy, then we play the game, right? If you can see if you're looking at this particular one. So if it is overcast, I play. If it is sunny and hot and high, then I don't play, right? So I want to know, given a particular type of weather on any particular day, would the guy play or not play, all right? Would the person want to play or not? So that is what we want to decide. So we have got data, the historical data, and now we want to apply a decision tree to decide on whether we are going to play. So if you look, I don't know if you can see that, can you get it? You can't? Yeah, sorry, ne? So, unless you come closer. But anyway, if you really look at that, I've taken outlook, all right here. I'm looking at outlook. I'm saying that if it is sunny, all right, if you look at that, what is outlook? It has only 3 variables. It's sunny, overcast, and rainy, right? That's the only 3. So I can, from here, it's a binary tree. I'm trying to branch off to different possibilities. So if it is sunny, and then I look at whether it is humidity or not. Is it humid? And then humidity is also of either is high or is normal humidity. So again, I branch onto high or normal. On the other side, if it is windy, outlook is rainy. If it is windy and I want to see wind, I've got only two types, true and false. So these are the two routes that I can take. All right. Now, if I want to predict something, for example, I was about to finish the whole chapter. Now you come in. Okay, so let's try. Let's see what would be would this person play if the weather looks like sunny and the humidity is high? How can we do that? How will we know? So we say outlook is sunny, so we follow this route, right? And then we say the humidity is high, so we follow this route. What's the answer we get? We say no, the guy will not play, which can be verified from the data. So this whole thing it has come up by the algorithm that we are using. All right, the tree is designed by using that particular algorithm, and it helps us in making the decisions that we are interested in. Making sense? Yes. Okay. If you say yes, yes, I must give you an assignment. Nah. To now do something. Okay, maybe just for. Let's say if the outlook, if this is equal to, let's say it's overcast. And it is a sunny day. Temperature, let's say, okay. No, let me not put temperature because my tree didn't make use of that. Okay, I'll make use of humidity. If the humidity is, what is humidity? Let's make it normal. And, okay, windy. Do I have wind on that thing? Okay, no, it's fine. So what would you say? Would you play or not? Huh? Would we play? Yes. Why? Why do you say we play?
Because based on our data,
yeah.
on number 7, we can reach a conclusion that the person can play.
Okay, based on this one. Yes. Yeah, or instead of look, because this is small data, and normally in life you'll get data which are in thousands. Thousands of rows with many features. These are known as features, okay? So here we have just got only 4 features. But in real life, you'll get many. So it will be very difficult to look from data and then come and find what the answer would be. That is why we are using the machine to help us do that, right? So the machine helped us in coming up with this decision tree. So let's just apply this decision tree to that particular case. I know it is a very foolish example, but if you really look at it, for outlook, that is overcast, right? You follow that one, and it's always a yes. The machine told us that if on a day that is overcast, we always play. If you look at the data also, overcast, we say yes. Overcast is yes. Overcast, yes. So it was always a yes. So the machine was clever. It could figure out that that's what it is. So no matter what humidity is, we always play, right? Now assuming it was not overcast, if it was sunny, what will we get there? Oh yes, for sure. Yeah, it's simple because Humidity, where outlook we say sunny, so we come this route. Humidity is normal, we come this route, and we say that the answer is yes. Okay, good. So we get a concept of what we are trying to do. All right. Okay, and just to mention some of the algorithms that we use for supervised learning. Again, as I said, there are many, many, many. All right, I've just listed 2 or 3 here. These are the most common ones that you'll find. So Bayesian learning is one of them. Neural networks is another one, and support vector machine is a third one. Decision tree was a fourth one. All right, random forest is another one. So there are many such algorithms that is used for doing predictions of these things, all right, for supervised learning. Now what else can I tell you? Okay, and where do we apply them now? All right, these are important stuff because many of you are still going to do your research part. You want to know where I can apply, for what kind of problem I can apply. So this is just giving you the different classes of areas where you can apply machine learning, all right? So a common one is for the face recognition, right? Of course, the applications, you can use that for many things, right? For security, for all kinds of stuff. So face recognition is one of the applications of supervised learning because you want to compare one particular face to something that we already know, all right? So we are comparing the features. We are saying, yes, this is the right person or this is not the right person. So we are giving it a label, all right? That's why it is supervised learning. Character recognition, very commonly used, I assume, with the banks as well, where they want to see whether the check is fraudulent or not. So whether you're forged. So instead of sitting and comparing the whole day, you give it to the machine, it will figure out. Obviously, because it has learned from past samples of your handwriting, whether it is you or not you. Okay, so that is a very good application of that. Speech recognition, the way you talk, it can tell you what kind of or who you are. For medical diagnosis, if certain symptoms are there, you can predict, or you can say what the illness is, right? If somebody is coughing too much, coming from China, you know. Sorry, no, it was just a joke. Yeah. Okay. And then also, when you want to do advertising, I think web advertisement, you would have all seen that, you know, especially when you go to Yahoo, Google, what have you, if you're looking for a particular book, then it automatically recommends you that, okay, similar books of that topic. Right? You want to do machine learning, you're hunting for machine learning, it picks up that this guy is interested in that, and it starts recommending books of that kind, or similar books, or books that have been bought by other authors who bought this book. Right? You have seen all that. So that is all part of advertising, which makes use of machine learning, supervised machine learning. Okay, so it's a very good thing. Those who intend to do recommender systems, for any kind of application, this is one of the things that you might need. A tourist comes from here, there, that's what they do. So let's take them to Kruger National Park. Okay, any questions on these? Are you interested in what I'm saying or not? You are? No, don't say hey, hey, I worry. I worry. Look at this now, I don't have to ask. Okay, let's settle in, please. Okay, so we looked at what is supervised learning, right? Now let's look at what is unsupervised learning. Now, unsupervised learning, the main difference is that we don't have the feature, the label that I'm talking about. In supervised learning, we had a label. We used to always compare something to something. Here, we don't have that particular label. It's basically used for kind of clustering, okay? Like, for example, I've got a basket full of fruits. Fruits in the sense there's bananas and apple, right? Now, I want the machine to kind of sort it out for me, or to be able to say that, okay, here is another fruit. Tell me what, is it an apple or is it a banana? So it will be able to decide on what it is by the feature of the fruit. For example, you say banana is yellow color, it's long, whereas apple is round, its weight is so much. So those are the features that you'll have to compare with, right? Come up with that, and then you take a new instance of something and you say, oh, it belongs to that particular group, the group that belongs to apple or something like that, right? So that is unsupervised learning, where there is no supervision. So as I said, that there is no, the data is basically unlabeled, all right? So you have to learn how to cluster them, group them without any labels. So you want to basically see which is similar to what. That's all what you're trying to do. That this thing is similar to this particular thing. For example, customer segmentation, you want to divide the customers into certain parts. You don't care about who it is. You just want to know this guy belongs to this group or this guy belongs to that group. So that can be an unsupervised learning. Image compression. Now when you have an image, let's assume it's a black and white image. So all what image compression is, counts the number of black pixels and counts the number of white pixels, and then groups them up and puts them in separate sections, right? And says that you have got so many thousand black ones and so many thousand white ones, right? So it uses that kind of thing. So image compression is a very useful technique for unsupervised learning. And another area is when you want to see, I think is it, on the web, you want to get to the news, like Google News, for instance, right? So if you click on particular, for example, when I did this, I clicked on President Zuma, all right? So when I clicked on that, it then started popping up with all the articles that was published on that particular topic. So Mail and Guardian showed me what it was talking about. Then also this other magazine told me what it is about. So it is all basically clustering. It is just grouping them up. It doesn't care about what it is. Just that I said this particular thing, so it said, okay, let me bring you all the articles related to that story. Clear? So there's a whole lot of applications that you can think of using these simple techniques. Okay, looking at the last one, the reinforcement learning. This is slightly different from the two that we have looked at. So reinforcement learning is an area of machine learning inspired by behavioral psychologists concerned with how software agents ought to take action in an environment so as to maximize some notion of cumulative reward. If I put it in normal language, what it basically does is that, for example, if you're playing a certain game, let's say you're playing chess, all right? Now, in reinforcement learning, what happens is that for each move that you make, you want to see whether the outcome at the end of the day, did I win or did I lose, all right? So if I say that, okay, when I moved like this from this point to this point and then to that point, my result was a win, then I stored that, then I learned something from that, all right? Whereas if I took certain steps that led to my failure, then I say, okay, in future I must not take these steps. So I continuously learn from the feedback I get, from the reward, all right? So every time I win, I say, okay, I must remember that I must move certain steps. Otherwise, gee, I'm bound to fail. So it is all about simple reward feedback, right? Whether did I pass or did I fail? If I studied only for 6 hours, Dr. Lal will fail me for sure. Then you know what to do after that, okay? So you learn from your experiences of that. Okay, putting it in some figures there. Here is my agent, this clown here. All right? So what he does, he takes certain action which in a certain environment, all right? Because he lives in an environment. So he takes certain actions and then they observe, did I do well or not? If not, I interpret my state of it and I say, okay, I learned something from that. And I keep doing that several times. Each time that I start winning the reward and everything, I store that. Professor. Okay, now please come. Okay, sorry, just for 1 minute. Nah? This Professor Pius, the one I showed you right in the beginning, we are going to be teaching together the in-depth part of it, right? When you start specializing into machine learning and all, he is going to be the chief. Prof, if you can just tell me.
Okay, I won't be here because I'm going for another class now. That's why I said that I will just spend my 5 minutes with you, then I move to another class. It's a kind of collaboration with Dr. La. The one that we're going to champion the AI, machine learning, data science, and all those stuff. And what we decided is basically we will take you through the pure AI class. We look at it in 2 or 3 different ways. The first one, we look at different platforms we're going to use. Basically, we use MATLAB platform, we use Python, we use Waker, and we use R. Those are 4 we're going to use. Our interest is first of all to give you the basic, the fundamental of everything before we launch you into the problem, because we aim to make sure that our program is very interesting, because we definitely need your attention. Each of the lectures takes the whole day. That means we're talking about, we intend to cover the area of the basic fundamental of the AI statistics and the math around AI and machine learning. We cover that. Then we're also going to zoom down into the area of your supervised or supervised learning, your semi-supervised reinforcement learning, and the assemble method. We look at all those things holistically. And it's going to be hands-on anyway, because we give you the math, we give you the theory. We also take you to make your hand dirty as well. In other words, we're going to use tools like Python, we use tools like MATLAB, we use tools like Wakers and R to make sure that we simulate it. Then we launch into the problem. And our area is to look at the sentiment analysis, for example, which will be our area, to connect the AI with IoT, to connect AI with different applications and see how they work, with you. And those are things that we're probably going to cover, basically, to make sure that we ground you in theory. Because the problem is that if we leave you to say, okay, you want to do AI, you don't even know how to take A plus B and cohesively use it to solve problems. But we teach you and solve problem alone. You solve the problem, but that problem, it doesn't mean that we make that problem your masters. No. But we ground you. We ground you in it. Then you have the skill. That skill will be with you. Is that skill now that you now need to use to solve different problems. But what we decided to do is to really build you up from the ground, because that will definitely help you a lot, And I think that's what, as soon as you find, I think Doctor will just, we start and you guys find yourself available, But we don't want big class, we just want serious class. Thank you, enjoy your day. Bye-bye.
Thanks, Prof. Thank you, Prof. Yeah, so you heard the Prof, right? So I think fundamentally for computer systems engineering and for computer science, there's going to be one area that we are focusing at, okay? Obviously the other professors would have come and told you what their interest is, right? So you guys can decide which matches with your interest and continue with that, all right? So I assume most of you are here from computer systems engineering? No. Okay. How many of you are from computer systems? And from computer science? Okay. Okay, so it's about 50% basically. No, it's good, because we are going to drill you, as the Prof said. Yeah, there's no time for playing. Okay, so we looked at supervised learning, we looked at unsupervised learning, we're looking at reinforcement learning. And then obviously there's the fourth one, which is ensemble, which is a mixture of different techniques, all right, that we use for looking at trying to improve the efficiency of our predictions or what have you. So if we're continuing further with the reinforcement learning, if I look at the different components of that, it consists of obviously the environment and the agent state, and then obviously the set of actions that it is, You have to give it the set of actions to the agent, and then decide a particular policy that it must follow to decide whether it wins or it doesn't win, or kind of thing. So that is reinforcement learning. The applications of that, I think I've got, yes. I think when you go home, you can watch certain YouTube. This is one link to that. Right? It's basically, I think, it's a toy helicopter, which was, I think, which uses reinforcement learning to learn how to fly. Right? So avoid, for example, it knows that, okay, if I go like this, I'm going to hit a tree. So from that experience, it then comes back and then maneuvers itself. So it's a very nice video from Stanford University. The guys there did that. And it shows you how the helicopter, after several tries, it keeps on improving, learning. Its performance becomes better and better till it is able to fly perfectly. Okay? So that is reinforcement learning. Okay, and then where do we apply all this machine learning stuff? I think natural language processing. What do we mean by that? I think Prof mentioned something called sentiment analysis. All right? Now, if I explain to you a bit, for example, you know, many people do some tweeting, Twitter or Facebook or something. Now, if you can extract those data, let's say, for example, from the Twitter feeds, all right? Now, this is normally in terms of, it's unstructured data, right? It's not structured as you saw in the tables and what have you. So now we have to use different techniques for how to get the topic that we are interested in, right? And that falls under the natural language processing. There are many people. For example, one of my students is doing sentiment analysis for the traffic conditions, right? So if you know that if the feed says that, okay, no, there's accident here, or I'm cut fall with this route or something like that, then you capture that and then you decide that, okay, I don't need to go that way, I'll find something else. So there are different things that you can use it for. So natural language processing, so it's a very good area. Computational biology, again, you look at different, well, we are not really any biologists here, but if you look at the different genes and the patterns that is there, so from that you can predict many other things that you would want to learn from that, right? So the computational biologist guys, they use this machine learning to model their stuff that they are interested in. Computer vision, very important again for machine learning, right? You want to detect something, you apply that. Robotics is another area. I talked about recommender systems, where you use this thing. Face recognition, I've talked about. Assistive driving, again, it's a new area where the cars learn to drive on their own, right? You have seen that, self-driving cars. So I think many of the states in USA already allow that to happen. So the training of the cars is done by the machine learning. They've got all kind of sensors and cameras and all that, which continuously feeds information, and then they drive according to that. And obviously there are so many other areas. The whole idea is that you guys start thinking about where you would want to apply if you're interested in that area. Okay? So, okay, I think I'm coming more or less. What are the other fields related to machine learning? Okay, data science is one of them. Right? Okay, data science, also known as data-driven science, is an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insight from data. Okay, I think this is something that we do quite often here. I think many of the students that I have, or some of them, not many, some of them, they basically look at the ITS student records, right? Okay, who was registered when, what are the subjects he did, how many did he pass, and all that stuff. So they look at the patterns of the students, and from that they try to see, okay, what can they learn? Because that's just data. So how do we make some sense out of that data? For example, I know that, especially for diploma guys, that people who do TPG and they do another complex subject, the chances of them passing, the probability of them passing becomes lower. So all these are useful. I'm just giving an example. If you do web and multimedia, you know you'll pass for sure. Sorry, it was a joke again. So yeah, so basically what I'm trying to say is that the data as it is not very useful unless you apply these techniques and try to derive what you're interested in, to answer certain questions. So that is part of data science, okay? It's one of the steps that we have. And as it is, you can see they're very related. Even machine learning is all about that. You take data, and from that you come to a model, and from that model you try to predict something, right? Or analyze something. Okay, data science obviously is linked to many other areas, as I showed you about machine learning, mathematics, statistics, information science, computer science. These are all part of data science, okay? They're related to each other. Data mining is another technique that uses data science, uses machine learning. If I may just again explain, the real machine learning is designing of the algorithms, all right? For example, support vector machine. It is an algorithm written by some people. All what we do is that we take that algorithm and we say, here's my data, apply it, all right, with some minor tweaking of that system. But the machine learning would be to understand these algorithms, to improve on these algorithms so that the efficiency becomes better, all right? And also to come up with your own algorithm. That is the actual domain of machine learning. Here what we are doing is that we don't know. If I tell you use logical regression or decision tree, you don't really need to know what it is. You just need to know how to do it. And when you start using MATLAB or Python or these are just simple import of certain libraries. Now you import this package, you have access to that. So then you are just playing around with Mickey Mouse kind of stuff. All right? See the eyes going big there. Okay, so are we there? So it's basically applications of these things that we are doing for data mining, data science, all that stuff. They're all interlinked, very similar to one another. It depends on how serious you are to pursue these things. Okay, data science is a science which uses computer science, statistics. I think I've told you about that already, haven't I? Visualization, human-computer interactions. Let's not waste time on these things. Data engineering, how does it differ? Well, basically, if you look at our country, the jobs that they apply, if you go to PNet and other things, there's a data scientist or data analytics or something like that. But if you really look into what the job profile is, that the person that they want, there's not much difference between the two, right? They still want to do the same thing. It's just different names given to that. But in certain other places where these things have really developed to that extent, there are different job criteria set for different jobs, okay? For example, then there's a data engineer. Now, what is his job or her job? Now, so it looks at basically the data infrastructure, all the server-related issues, the computers, and then the data architecture. That's again a very important field that people need to know. So there is a data engineer. So data engineer gathers and collects the data, stores it, does batch processing and real-time processing on it, and serves it as an API to data scientists who can easily apply that, okay? Am I right? Making sense? Yeah, say yes, man, even if it's not. Okay. Data mining, again, the whole process is trying to get knowledge from the data. All right? What can the data tell me? That's what it is about. It's trying to discover knowledge. So it's the process of analyzing data from different perspectives and summarizing it into useful information. Information that can be used to increase revenue, costs, and all that stuff. So that is what data mining is. And, okay, don't want to say what I was about to say. So technically, data mining is the process of finding some correlationship or patterns among dozens of different fields and then trying to make sense out of that. So application of machine learning methods to large database is called data mining. It's application of machine learning. That's what I was trying to explain to you, that we don't really do machine learning as such. We're not going to ask you that go make this, come up with an algorithm of this kind and that kind and improve the efficiency of this thing. Okay, so if I look at the data scientists and what is the knowledge skill set that they must have, now it's asking for a lot, but still that is what it is. You obviously have to have the knowledge of that domain. For example, if you're in the banking sector, you must know what those terms and technologies. That's my phone. It doesn't normally ring, but it rang. Sorry, it's rare. Okay, I hope that is switched off. Okay, if you get back to that, so you obviously have to have an understanding of the domain where you're working, and then you also have to have some scientific knowledge for understanding machine learning, statistics, how to do analysis. You need a good knowledge of that. And then also the engineering part, like programming and all that. So you have to have an understanding of Java, Python, Hadoop, Spark. These are tools that is used for big data. If you want to analyze big data using simple tools like, well, simple Python, if I may just say, is going to be a lot more difficult than if you use the proper tools like Hadoop or Spark, Pig. There are so many others, all right? So you have to have it, your knowledge must be broad if you really want to do very well in that field. Clear? Good. Okay, and then these are the different stages of data mining. If I may look at that, it's quite okay. So here we have got data. The whole idea is that from data we want to get to knowledge, right? So how do we go? You just can't take data, put it into a machine learning algorithm and get the knowledge that you want. Nah, that's not how life works. So the data that you get will be normally quite messed up. It can be in different tables, different formats. Some maybe you have to combine them into one table if you want to. And then obviously you also have to kind of select for a particular problem. You have to select the features, as I was telling you. You have to do a lot of pre-processing of the data. For example, you might find that there are many fields or many fields that are missing. You have got missing data, or you have got data that is clearly outlier kind of a thing. So you need to go through that, clean up the whole process, and then after that you have to, after you have done the cleaning, then you have to now start transforming it into the way that your machine understands. For example, not all algorithms work equally well with for every kind of data. For example, linear regression will work only with numeric data. All right? It will not work with data where there is, for example, strings, categorical data. So that you'll have to now think of decision tree or something. So all that you have to start now transforming it. For example, in that playing tennis thing, right? What was our label was whether he plays or doesn't play, right? So I could have easily used a number like 0, not play, 1 to play. So all that tricks that you have to play around with the data, that will fall under the transformation of your data. There are many techniques. They're in-depth. I need a whole semester if I want to explain to you to all this, properly, that is, because just knowing is good, but yeah, I hope when we go into depth, you'll be able to understand what we are talking about. So having dot, now this is where you start now applying your machine learning thing, particular algorithm, and then you get the results, and then you start interpret what it tells you, and then you say, okay, wow, I've learned something new, right? So that's knowledge that I've acquired. So this is the normal life cycle of a data mining thing. So whenever you have data, whether you're using for machine learning, for what have you, it will follow most of these steps. Clear? Okay. Okay, it's the same story I've been telling you. Data selection, data cleaning. This will be provided to you, I assume, the slide. It will be uploaded somewhere, then you download it somewhere. So you can do that. So you can read this, I don't have to read line by line. No, it's not a good thing. Data transformation, data mining, pattern evaluation, decision, knowledge discovery, you read for yourself. Okay, there are certain areas. Let's just look at this quickly so that we have an understanding of what it is. So data mining applications in sales, for example, and marketing. There's something called market basket analysis. What is a market basket analysis? For example, you analyze, let's say in a shop, all right? You analyze everybody, what they're buying, right? And then you say that, okay, somebody who is buying beer on a Friday, would also be buying cigarettes or something like that. So then you say that, okay, I've seen that this is the pattern that is there in the normal stuff. So you can now start placing your items together, or you can put them far apart so that people have to hunt around your shop, so that they pick up something new which they didn't want to buy. So you can do all that stuff. So that is market basket analysis, all right? Then obviously identifying customers' behavior, how they buy, that's all part of that. In the banking sector, credit fraud detection is very important. For example, you know that this person, he stays in this area, so normally he does his shopping here. And suddenly you see that he's buying now in China or in America. No, not China, America, they say. All right? Then you know that, okay, but in the morning he was here, now how come he's already then doing shopping? So you can detect such fraud. Sometimes it's really applicable, because I get also phone call saying that, that I see you buying this and this and this. Whether it's you or not, please say yes, no, kind of a thing. So it's all kind of this. In healthcare, again, when you want to claim analysis, you want to see whether the doctors are putting in false claim or not, which is away from the normal pattern. You can do that. Fraudulent behavior. So there are a whole lot of areas where you can do this. But obviously, you need data. So before you decide that, I want to do this, make sure that you know where to get the right data from. Without data, there's nothing. Okay, then you can apply it also in transportation, you can apply it in medicine, for all this kind of stuff. Okay, I think this is where I stop. I don't go further. Okay, this agent-based modeling is just an area where I also supervise students. So, but because my job is to tell you only about machine learning, so I don't go into this, right? So that's what it is. Is there any other question? Any question related to what I've said? Okay, so I'm not going into modeling, so don't worry, I must say thank you. Okay, thank you so much. Now, is there any question?